Hello, my name is Stephanie LeBeau. I am the data science librarian at UC San Diego. And today we have with us John, Mindy, and Sarah from ProQuest. And they are going to be talking all about ProQuest TDM Studio, which is a really great platform for text mining really large amounts of data. So with that, I will say again, feel free to put any questions in the Q&A as we go through the presentation, and then we'll have some Q&A time at the end. So with that, I'm going to stop talking. I'll let the ProQuest folks start us off.
Thank you, Stephanie. So I'm just going to go through a couple slides, give a high-level overview, and then hand off the most interesting part to John to give us a demonstration of TDM Studio. And we'll focus a lot on that portion of TDM Studio that's been out the longest with the workbench, and then also talk about some new and exciting features where you don't necessarily have to know how to code in order to execute text and data mining. So our goal really with TDM Studio is to solve lots of challenges around gaining access to these really large data sets. And when we say large, we normally talk in number of articles or number or number of documents, so millions of documents or thousands. I know sometimes we also talk in size of like gigabytes of content also, but really providing access to some of the most sought after content that we have for years received many requests to have access to current newspapers like the Wall Street Journal, the New York Times, today's, or all the way back, for example, the New York Times, you can do an analysis over 170 years. So looking at trends and patterns and having efficient access. When we have been developing this product that we just launched about 10 months ago now, we really wanted to make sure that we could provide access to the content in an efficient manner because a lot of our researchers told us they were spending months trying to, whether it be negotiate rights or find the content, or if you're getting it from multiple sources, cleaning it so that you can have a common data format across all of that content. We really wanted to make sure that our users could do it in hours rather than in months. And then we also, the last piece here is that we want to be able to introduce text and data mining without necessarily requiring that our users know how to code, but they could begin to understand the concepts of text and data mining, whether that be geographic analysis or topic modeling, and do that without the requirement to know how to code in R or Python. So with that said, we want to be able to, for users across disciplines, this isn't just digital humanities, but it's business, it's sociology, history, journalism, sociology, and the list goes on about the content within ProQuest, whether it be newspapers or ProQuest dissertations and theses, scholarly journals, is really applicable to all types of disciplines. And now that TDM Studio supports what I like to refer to as two research pathways. One that we'll start with, and that we did start with our launch in April, is more on the right-hand side here, where those researchers do have to know how to utilize the programming languages of R or Python in order to execute their text and data mining. And in December, we launched our first, what we call data visualizations, so that users don't have to know how to code, can create data sets still, and then utilize the visualizations to help understand the patterns and connections between the content, and then begin to delve a little bit further. They can export content, and then hopefully the long-term pathway being if you want to learn how to code and execute through utilizing the languages of R and Python, the TDM Studio supports that full pathway. But rather than me talk about it, I think it's best if we give John time to demonstrate the power of it and the ease of use for creating those data sets. So with that said, I will hand it over to John to walk us through TDM Studio.
Thank you so much, Mindy. And thank you, Stephanie and Harold, for giving us some time to speak with you all. We're really excited about the solution, and it's been great developing it over the past few years, and this will probably be the quickest demo of the solution, the two components. Feel free to drop any questions in the chat, and we can definitely tackle them. as we go, and if there will be extra time at the end as well. So the demo will be for about 12 minutes. That's the target here, and then it should leave at least 10 minutes for Q&A. So there are two components to TDM Studio. The first is lots of data, programmatic access. That's kind of component number one, and that's what I'm going to show first. That's, as Mindy described, if you need access to millions, even hundreds of millions of documents, component one, which is what we call the workbench. You log in through a web browser here, and it takes you to your TDM Studio workbench. And this is component one for folks who write Python or R code and want to write lots and lots of code against lots and lots of content. That's actually the quickest way to summarize the product. Lots and lots of code against lots and lots of content. And you can create a data set here using this flow, which I will show in a minute. You can have up to 10 data sets at a time. Each data set can have up to 2 million documents. You can delete the data set and you can loop through more data if you wanted, extract more results and findings. Then up top here, you have a Jupyter Notebook link, and you open up a Jupyter Notebook that supports Python and R, and you can run the analyses against the data sets you've created. So two key pieces here for this first component. So to create a data set here, I click on create a data set. I have two options. One is to go with specific titles, or the second option is I can use ProQuest collections. This is what we call databases. So let's go with the publication titles. So here we are. I have access to about 70,000 publication titles here. Let me just type in one here. Let's go with the New York Times. Let's try this here. And oh yeah, here we have several different versions of the New York Times. So lots of contemporary newspaper content. I'm going to select this one, 1980 to the present. And let's actually add one more, the Wall Street Journal. Oh, yeah, the Wall Street Journal. Let me add this one as well. And then we're going to take a chance here. We'll go for 3, Washington Post. Washington Post. Let's try this one as well. So the content in the studio is really strong in, let's go here, this one here. It's really strong in newspaper content. So really strong in newspaper content, and then also dissertation and theses content, and then also primary content as well for history and literary studies. Those are kind of 3 strengths as a company, and each of those 3 strengths shines in this product. We've had about 50 different research teams supported through TDM Studio already. The product's been live about 1 year. And those are the 3 research strengths. So contemporary news content, you can data mine today's newspaper in TDM Studio. You can actually see that here. So February 9th is today, and you have access to the Wall Street Journal newspaper content, full access, which is great. So I'm really interested in Bitcoin at the moment. So I'm interested in looking at Bitcoin and looking at how what the newspaper talks about impacts the price of Bitcoin. So what people's perceptions are or representations are of Bitcoin within major US news outlets and how that impacts the price of Bitcoin. So we have major US news outlets selected here, search term of Bitcoin. This supports full search refinements. You can use or you can use proximity searching. Also, you can search specific fields and wildcard searching as well. Any metadata that we get or add from the content providers is provided here as well. So this is kind of a small data set, 2,000. I could expand this to hundreds of newspaper titles if I wanted, but we'll just leave it at 2,000 for now. And then I go to the next step. I give my data set a title, Bitcoin 2.9, and then I create the data set. So this will take us back to the starting screen where you'll see the data set which we have just created. We won't actually use this data set. We'll use another data set. The data set creation is quite quick. So we process about 100,000 documents an hour. So within, if you make a data set request overnight, you could have multiple millions of documents we've seen. So you can see at the bottom here, Bitcoin, let me actually refresh it here. You should see the most recent one. And then, yeah, 29-2000, it's queued. This will be ready in a few minutes. So quite interesting, right? Interesting. Okay, so that's how you create your data set. Next thing is you access the data set for analysis. So I can open my Jupyter Notebook here, and this will load basically a Jupyter Notebook that's running on our cloud servers. And this is where you can run and write analyses against the data sets you've just created here. So these same data sets, you can transfer them so that they then are available here. These are basically large folders, folders with lots of XML files, and then you can write scripts against them. We support fully Python and R, two commonly used data science languages, and we also provide documentation, extensive documentation, how you bring stuff into the studio, how you bring stuff out of the studio, how do you export your findings. Anything can be exported as long as it's not full text. So any sort of derived results, any sort of derived features, bag of words representations, any of that can be exported. And then we also have, what's pretty cool is we include samples as well. So there are different types of samples here. Standard analyses that we've seen again and again, taking documents from XML, converting it to a data frame, creating a document term matrix to represent documents as a bag of words, looking at things like topic modeling, or what are the most common entities in a data set about Bitcoin. I mean, who are the top people? What are the top places or geographic entities? Things like that are all possible with some of these sample scripts. What's cool is that all of ProQuest content is in the same XML structure. So a data set or a script that you write against one data set should work against all 1.7 billion documents. So pretty nice on that front as well. I'll just show one example, which we're currently working on releasing. This is a sentiment analysis script. So what we're looking at here, we developed this model with the University of Michigan. Actually, this model, you point it at a newspaper data set, and it attempts to predict the affective state or human emotional state of the sentence. So instead of sentiment analysis usually uses instead a valence score of -1 to +1. And here what we're doing is we're actually trying to predict the affective state or the emotion labels. So you can see most newspaper sentences within the sample I'm looking at here are neutral, but there are some cases of other data sets as well, which is pretty interesting. I mean, this is quite valuable because it provides more nuance to understanding human emotion instead of just the -1 to +1 valence score. And in my particular example of Bitcoin, you can imagine saying, okay, well, we now have this article, this data set about Bitcoin. I want to look at the emotional states describing occurring in that data set regarding Bitcoin. Obviously, I haven't yet figured out the link between the Bitcoin price and the sentiment expressed in newspaper articles. You can then take this result, you can export it to a CSV, and then you can hook that up with other data outside of the studio if you want. You could also bring in outside data to your TDM studio. This could be done, for instance, you could bring in the daily closing price of Bitcoin, which could be pretty interesting. So that is the first component of TDM Studio. Create a data set, conduct analysis, export results. Now I'm going to move ahead, and in the next 4 minutes, I'll show you the other piece of TDM Studio. One thing we heard loud and clear was that there were a lot of folks at university, at different universities who didn't know how to write Python or R code, or didn't want to write Python or R code, or they wanted to introduce their students to text mining in broad context, maybe just for 15 minutes in a library discovery session. Maybe they wanted to use it for 30 minutes in a history class so that students knew that these types of methods were applicable and offered new ways of understanding large textual resources and historical narratives. So yeah, so in that vein, we developed another component to the solution, which we're calling the visualization dashboard. And this specific dashboard is very similar to the other dashboard, except no coding is needed for this piece of the solution. You create a project here, just like we did with the other flow. Let's say drinking water and lead you're interested in. These data sets are somewhat smaller. Let me just get rid of that. And they are somewhat limited based on their content. Again, the goal here is to keep folks on a path which leads them to success with data mining. And then if they want to explore the underlying code which is driving this, they can do so on the workbench side, which is, they're quite complementary, coding and non-coding, but I think there's lots of overlap in use. So here I'm looking at drinking water and lead, again in US newspapers. And this data set will complete relatively quickly as well. It's about 6,800 documents. So what's going to happen here is we're going to extract the geographic locations from the newspaper articles, and then we're going to plot them on a map. It seems like such a simple task, but as you likely know, it's quite a difficult task because there are lots of place names, which are also people names. For instance, if I say, I met Charlotte for lunch, is Charlotte in this case a person or a place? It's probably a person, or most likely is a person, but we also know that there's a Charlotte, North Carolina, which is a place. So this is the data set here. It's in process, but we'll go down to one I've already made, and we can actually open the geographic analysis here. So this is the same search terms, drinking water and lead. So we identify which terms or words in a document are locations. You can actually see down here, Charlotte right there. Interesting, right? And then is the tricky task of saying, okay, so are you talking about, let's say if I say I visited London, did I visit London in the UK or London in Ontario, Canada? Quite challenging thing. There's actually lots of these cases. How many main streets must there be in the United States? So that's the second piece, is how do you handle the geocoding piece? What's interesting here in this exact example is, even though we know there's large cities on the West Coast and the East Coast here, the bubble that sticks out is this one in Michigan. And you may have already guessed it, but this large bubble is sitting on Flint, Michigan here. And even though Flint has less than 1/15 the population of Chicago, we have almost 3 times as many Flints on the map as Chicago. So this is of course due to the Flint water crisis. So Flint switches its water from Lake Huron to the Flint River, causes pipes to leak lead. We can even go back 5 years, 2015, no Flints on the map. Look at that. And then you go ahead 2 years and you get all these articles that contain Flint and are talking about drinking water and lead. So kind of an important example. And this, you can click on a cluster and it will list the articles which contain Flint, Michigan as a location, which has been resolved to Flint, Michigan. You can view these articles by clicking on the links. So interesting from a discovery standpoint to find new research items via a geographic distribution. You can also export the metadata and the geographic data. So this tool hooks up well for teaching and learning. Let's say if you were teaching a class on geographic analysis, this would be a nice way to introduce students to that type of process. So, and then they could extract the data, they could look at, and they could think through, well, why did it get Flint wrong? Or why did it put London, Ontario in London, UK? What are the reasons and things like that? Fully transparent algorithm, and everything is built on open source softwares and technologies. So I'm just going to pause there. I will just conclude by also saying that we've been working pretty closely with Stephanie and Harold, and if they have any additional comments or thoughts on how the solution rollout and support and interest has been, I would welcome their comments as well.
Thanks, John, and thanks, Mindy. Yes, so I do want to mention that UC San Diego currently has access to the workbenches. And then UC Berkeley does as well. And at the moment, I think those are the only 2 that currently have the workbenches available to work with R and Python. But I think I'm saying this right, that any of the UCs can use the visualization component. Please correct me if I'm wrong about that.
Only the UCs that have subscriptions can use the visualizations. So
Okay.
the schools that you've listed can use, I think, Mindy, is there one? I thought there was one more UC that was also on board.
UC Davis is also just getting started.
Yeah, that's exciting. So 3 UCs, both workbench access and visualization access. And yeah, back to you, Stephanie.
Yeah, so and this is where I'll say too, if you ever have any questions about this kind of, do we have access? Don't hesitate to reach out to your library. And if your campus doesn't currently have it, might I suggest finding a collaborator on one of the campuses that does have access? It's a great way to form collaborations across the UC and kind of get access to some research that you might need and form a new research collaboration in the process. So we do have a couple questions. One that was answered by Mindy, but I want to recap because it's pretty important. So the question was, is there a total limit on the file size? So Mindy mentions that each of the corpora that you make, each data set, can have up to 2 million documents. But I also wanted to pause because there is an export limit. So if either John or Mindy could mention the export file size limit.
Yeah, absolutely. That's a great point. So there's a 15 megabyte rolling export limit, and that is basically derived results. So derived results can be exported up to 15 megabytes a week. And also we do make exceptions to that limit for larger models, larger scripts, larger result files as well.
Great. And I will say, anecdotally, I spent quite a bit of time on the workbench playing around with it. I will have a caveat. If you try to text mine 2 million documents at once, it doesn't work. It'll the AWS server instant will actually crash out before it finishes. So if you ever have any questions, obviously if you're at UC San Diego, feel free to reach out to me. I've spent quite a bit of time kind of poking the limits of what is possible, as John, Mindy, and Sarah all know. Or if you're at another campus as well and you're curious, feel free to reach out as well. Okay, there was a second question, which I think is a great question. So is it possible to run any of these analyses in RStudio, or is it only in the notebook?
So that's another great question. I mean, currently everything is in the R kernel is the supported through the notebook interface. You can, however, if you are more comfortable working in RStudio, we do also send a few sample XML files if you want to work with those in RStudio and then move your code up to the TDM studio. That's another option. And then, of course, you can always create derived data set or feature sets within ProQuest Studio and take those out and then use those on RStudio in your local personal laptop.
And I would echo that as well. That tends to be my workflow as well, either doing the pre-processing on Workbench and then exporting, say bag of words or ngrams or something for more local analysis, or the inverse. So developing code locally where I'm more comfortable and then transitioning it to the notebook format. So it will run R perfectly fine. You only won't have the RStudio interface, but definitely developing your code locally and then using it in the notebook works totally well. Any
That's a
other
great point, yeah.
questions? I will say that anecdotally, I mentioned I've spent some time working on it. It's great. There's a ton of content in there. If you are currently at, I can only speak for my personal campus, but if you're currently at UC San Diego, the way to get access is going to be to email me. It's all over the library website. It says, we've got ProQuest TDM Studio, and then you'll email me. And it's to make sure as we start ramping up our use of this, that we are not, overwhelming ProQuest right away. So, but, as long as you have a legitimate research question and you're an affiliate, that's kind of our distinguishing characteristics, then we'd be more than happy to get you set up on your very own workbench. And you can go ahead and start making your data sets and analyzing everything. We've got all the cool newspapers, and there's some really interesting stuff in there. And if you ever run into any problems, TDM Studio has a help email, and they've also been really responsive in terms of taking suggestions that we have. Ooh, looks like we do have another question. How much does, let's see, how much does TDM Studio cost?
Yeah,
It'll
Stephanie, I'll
depend.
take that question. No worries to put you on the spot. Yeah. I mean, it depends on what you're interested in. If you're looking for the campus of, doing a single workbench or unlimited workbenches, we can definitely have your account manager reach out to further discuss pricing, which I think is probably the best way.
I see another great question here from, looks like from Joe. To gain access, can we just create an account? The question vanished.
Oh, sorry, that was
No, it's
me.
okay.
I
No,
was
it's
doing
okay.
the answer live. It's do we create an account directly from the website, or do we need to go through our library?
You want to tackle it, Stephanie?
Yeah, sorry, I went to answer. Yeah, so you will need to, at the moment, I'm pretty sure it's the same for Berkeley. John and Mindy can correct me, but for San Diego at least, you do go through the library. And so you request, you tell us that you want access. We handle everything on that side, and then we get you set up. At the moment, there is no option to kind of use your single sign-on to make an account. So it is semi-mediated, so you will have to go through the point person at your library. But by go through, it's a really low effort. You email, you say, hey, I'm so-and-so in this department, I'd love to get access. I email John, Mindy, and Sarah, and I say, we've got this great faculty member or student who wants access. We get you all set up. And then it's also a way for us to provide lots of instruction. So like when I give access to new people, I always include some benchmarking data so that you know in advance, if you're trying to text mine 100,000 documents, about how long it's going to take, so that you're not concerned if it's 3 hours later, because it is gonna take a while. So we use it as a way to just make sure that you have all the information that you need. But for now, you do have to go through the contact person at your library.
The
That's
same is true.
exactly, sorry.
Oh, that's okay. The same is true for Berkeley also,
Okay.
until we'll be working with libraries over the coming year to figure out, is there a better workflow? How do we provide more control to you guys? But right now, that's the workflow.
Yeah, all amazing questions. Yes, it's the
Yeah, thank you.
logistics that are
Yeah.
killer. Okay, so that has us right at 12:30. So being respectful of everyone's time, I'm gonna wrap it up. Thank you so much for attending. Again, if you have questions, reach out to your campus library, or if you have a specific data librarian at your campus, which you probably do, feel free to reach out to them. Again, if you're at UC San Diego, that's me. Hi, I'm Stephanie. And thank you so much, John, Mindy, and Sarah, for joining us.